I'm going to try to cut this short, if you allow me, and try to finish by 5:30. I don't know if I will quite make it, but I'll see if it works. The idea is that I'm going to talk for something like 10 minutes, and then it's up to you. And if you don't say anything, it will be done a lot faster. Now, I want to first express my gratitude and thanks to Jed and Diana for the friendship they've shown me this year and for our long years of contact and collegiality that go back to our common friendship with Yuda Elkanah, who should be mentioned in this context. Now, I'm going to start by telling you something that I once, I was a budding historian. I'm not a historian of science. I come from a completely different camp because I started out as a Heidegger expert. And I remember reading something interesting written by Hans-Georg Gadamer, famous hermeneutician of the earlier part of the 20th century, where he writes the following. He says that great men, or great people, are independent of their context, so that we read them with reward 1,000 years later, and we never think to ask about their context. And as opposed to that, he said that when we see the absurd things that people believed in the past, we can't really convince ourselves that they believed this, and therefore we invent the contextual explanation for what they say. That was Gadamer. In other words, the contextual explanation is, he said, an explanation of idiots that we then apply to intelligent people with the effect, so Gadamer, of debasing what they say. Now, I don't know that that's I think it's an interesting, I'm not sure I agree with this, but I think it's an interesting point for a discussion. And the reason is that the history of science, unlike the history of the philosophy or the history of literature, as Noel pointed out in one of his quotes, history of science deals with obsolete science, with science that is demonstrably false. Not all of it, but a very large part of it. I mean, if you're dealing with Eryugena's theories, which go back to somebody else whom you might know, of earth, fire, air, and water, over 300 pages of the Periphyseon, you fall asleep reading them because you cannot make yourself believe one word of what you're reading. That's sort of interesting because it calls another kind of dialogue to account, which is the dialogue about the things we don't believe in. Now, if the things we don't believe in are somehow unconfirmable, then in fact the thought about them is very productive. That's, I think I can show, and a lot of people have shown, that thinking about God over the millennia has been extremely productive, even if the empirical proof may be somewhat lacking. That's like thinking about the ether. And one of the things that was said here that I recollected today was that thinking about the ether was actually productive, even though I don't know how many of you believe in the ether. I don't think anybody does. So, in other words, thinking about the non-confirmable is not the same as false science. That's an interesting observation. It's probably anti-Popperian. Now, it's true that the obsolete becomes unintelligible, as was said, but then it's something that we do too. We tend to mystify the past and turn it into an inaccessible country, which it wasn't. We seem to think that people lived according to entirely different motives than the ones that we have. Now, some of us have reached, including me, have reached the age of 70. And that means that we have already a fair proportion of the time since the first century. We've lived through a large part of it. And we do not feel over our lifetimes that much has changed because we have been constant throughout this whole time. And so we find it very difficult to mystify our parents and grandparents. Yet as historians, we do this all the time, and that's one of the ways in which we control the truth, because we say this is a mystical doctrine or an esoteric doctrine that only we have access to. There's something that offends my common sense in that. The other thing that we then do, and this I see again and again, is we invent historical periods. Now, nobody has ever lived in a historical period, not from the beginning or the end. There is no such thing. I mean, I take the moments before my birth, such as World War I and World War II, to be very important. But a moment I lived through, which is the collapse of communism, is trivialized because it's part of my life. There's a complete difference in dimension, and it's an imaginative one. And the reason is that we're always running up against people who are what the Germans would call unzeitgemäß. That's to say that they're out of their time. And that goes back to the Gadameryan comment, that you cannot reduce everybody to merely as a historical phenomenon. If you do, then you're in trouble, because you're then trivializing what they thought independently or their contribution. Now, I have a couple of other things to say, and I'll say two more. One is that I was very interested in the discussion about experiments, which was a theme throughout the day. And I thought, what is the difference between theory and experiment? One real difference is this, that theories have lasting power. In other words, you're affected by theories. You don't have to recreate the theory in order to be influenced or affected. Whereas an experiment is just a datum. So if you can only deal with the experiment if you want to take it seriously by running it again, or running a better experiment to show the same conclusion, or using a different machine. It doesn't have continuity. It has to be recreated. And because it has to be recreated or replaced by other experiments, which is the same thing. And that means that there's a constant war between the continuity of science and the what do I say? The pointedness, the point where it stops and where something else starts. And that this is something that I think is ineradicable. Now, let's see what else I have to say. Now I want to speak 1 second subjectively and say that, the categories we have for understanding the past are our categories. And I can draw examples from all over the place. Other people did not think of them. I'll take something obvious, not something that we all used to think about like class, which may or may not have existed, but gender. Gender has always existed. People in the 12th century were as aware of gender as we are, and yet their ways about thinking about gender were very different. Very different because most people identified with their families or clans or tribes or ethnic groups, and not particularly with these constructed categories of identification that are very important because they're part of our culture, and we can retrospectively cast them back. And I think that's a warning on the other side, because you say, okay, you say no contextual history, but the context is what differs the past from the present. And I'm saying that's not what differs the past from the present. What differs the past from the present is what did people believe to be true about the world. And that is the main thing that differs, that's the difference between the past and the present. And that is really different. And you don't have to have any explanation. It's just a phenomenological datum that people 1,000 years ago thought differently about every single issue that you can name. Now that leads to another remark that, we are all part of our culture, and none of us feels to be part of our culture. None of us thinks that we're part of a culture. If I asked you, what culture do you belong to? Not one of you could give me a reasonable explanation of that statement, if you do go introspectively. And the reason is that we see ourselves in a way as outside of time, and so we cannot analyze our own subjective belonging to what will be called reductively in dealing with the past as our culture. I think it's something that we should take into account. The last disjointed remark I have to say, and I was given an example even by Jürgen Wren, which I won't repeat because I don't know enough about the example. He can tell you about it, but this is that one of the things I learned from the very last session was that forget whether the data is true or not. The problem is this, that sometimes false data leads to true theories or is productive in terms of itself. That, in other words, not always, usually not, but the interface between theory and data, or theory and experiment, is not one-to-one. It's never going to be one-to-one, and that's, I hope, one thing with that I'll conclude. That's really all I have to say so far. And now the floor is yours. If you don't speak within the next 2 minutes, we're going to give up. So, does anybody have their hand up? So that, because I think my other job is, yes, over there at the end, in the top row. No, they want you on the mic. I don't know whether they're recording, but they're filming, so they must be recording. So then they want you to hear your voice.
Maybe not. I don't know. It's been a great first day, and I've written like 2 pages of notes with a billion questions. But I'll wait, since I'm moderating tomorrow's session, to include that. The one thing I wanted to bring up is where we ended with experiment and Diana's question.
You have to talk more clearly, because I'm not getting you.
I want to go back to Diana's question at the end of the last session, and which is why experiments are done, right? And I was never part of the replication of Cambridge, non è mea culpa, contingent. But that said, because I always told people like Otto Seebohm, if you don't get the results that people like Coulomb or Faraday got, chances are they're the really good experimentalists and you're not. The key is, I think, what you want, you don't have to worry about refuting philosophers on this. The fun about doing the important historical moment, and I think Alberto showed this brilliantly, is that the skills that are needed, the material culture that one gets when replicating an experiment or attempting to do so, that you don't get from simply reading the protocol, from reading the works. That's an important historical information that you cannot necessarily get in any other way. It's not about showing the philosophers that they're right or wrong. It's to show that experimentation is actually very hard labor. It's an interesting example of Handwerk and Kopfwerk. And you begin to reconstruct a bit of the historical aspects of the scientific enterprise in unique ways. That's what makes it so much fascinating and so much fun. And I think that's why we should do it as historians. We're uncovering important bits of information that are not necessarily given. They're given perhaps as assumed to be true, that if you go and buy wire in 1810, it'll work, where if you're trying to get that wire now, it's going to take some time to figure out exactly how one makes that. Skills that were very well distributed in certain aspects of society aren't necessarily present now. And that's an important, actually, social and historical fact, for lack of a better term.
Any reactions?
Danke.
Yes, John.
There's another interesting fact that comes forward from Al's experiment, which were very difficult and for which he deserves all praise. He may be the first one in the history of the universe who has actually done this experiment, because although he gets Coulomb's results, it doesn't mean that Coulomb got Coulomb's results. That's not my point, however. What I want to say is that, to me, the most interesting fact about it is that all these people failed to reproduce the experiment, and yet it made no difference.
That's right.
It made no difference in the history of electricity. People believed in the inverse square law, and one might almost say that the experiment was irrelevant. I'm not going that far, but let us say that it was. What does that tell us about theory growth and its dependent on classical experiments?
Over there, there's a hand right there.
So in addition to Miles' point that the replications of experiments provides information about the tacit knowledge and skills for the experimental work, I think there's another value for this bothering to go into the material replications of experiment, which is to get to know a bit more, not only about the material practice of experimenters, but also the material conditions of different kinds of experiments. So this sounds like a bit abstract, but just put it simply, there are different types of experiment to design and to probably verify or to testify the same set of scientific effects. And some are more stable and easier to replicate and easier to handle, and some are super delicate and extremely difficult, like the Coulomb experiment that Al spent months or even years to struggle with. So I think one, among other values, one values of pursuing the replication of the experiment is exactly to tell us how sensitive is an experiment to different types of material conditions. So if for some kinds of experiments the condition is not sensitive, then maybe it doesn't depend reliant, it is not super reliant on the precise material and hands-on skills that the experimenters need to undertake, right? So maybe changing different materials or changing different procedures won't matter that much, but there are some experiments that are that sensitive. So I guess another values of experimental replication is exactly to tell us about the material conditions and sensitivities of different types of experiments.
Manfred.
It's of course very interesting to ask that question from a different field, because if you look in the present day life sciences and social sciences, where more than 70%, and that's a generous estimate, of the experiments are in principle irreproducible, then we have a problem, or we have an interesting historical situation, and you might want to explore why. And one guess of mine and why this might be the case is that those experiments are not necessarily directed by any theory. They are just collecting certain things, put together an experimental system, measure something, and you don't really know what you measure. And that also means that you don't really report what are the necessary conditions that you need to hold constant for that experiment. So if the next guy comes around, tries to reproduce it and fails, then we don't have a theoretical framework to assess why they fail. And that's an interesting period, and it's a criticism of where we are in present-day biology and medicine, but it is something to think about.
Yes, over here.
One of the problems about
Speak to the mic.
one of the problems about the failure to replicate is the fact that there's good evidence that, at least in some fields, people will not report null results, nor will journals publish such null results. And that seems to be a real problem in certain areas. And this seems odd for those of us who work on physics, because some of the most important experiments in physics are in fact null results. But there is something, and I've been told this is true by psychologists and others.
Anything further on this point? I have, yes, over there.
I unfortunately missed the end of the last session, so I missed this stuff. My question is whether the question of other forms of reenactment as historical practice came up in the course of the discussion of experimental reproduction. Just because there is a relatively elaborate literature now, meaning like 2 or 3 edited volumes on historical reenactment, and it's pretty odd in certain ways, and I just wonder what would happen, if anything, if you were to juxtapose efforts to reproduce experimental results with what might seem to many of you facially unrelated instances of historical inquiry that passes through reenactment or performance, like Civil War reenactors or different historical impersonators who get interested in attempting to make themselves into instruments of other historical moments.
I have something to say about that. There was a reenactment about 15 years ago of the Battle of Hastings. And what they discovered in this reenactment was that even though everybody knew the outcome of the battle, because after all it had been fought a while ago, the troops could not resist streaming down the hill from the Saxon positions to the Norman positions and getting eliminated by the Normans once again because they looked to them to be in such a position of strategic advantage, even though they knew that the result was fatal. And so I just think it's an interesting point. There's another issue that I want to raise because I see the tension between theory and experiment here, and it's an issue that Professor Gley raised when he said that there's no good history of the last 50 years in mathematics, if I understood you correctly, or something like that. Too dangerous to do. And too dangerous to do in part because mathematical results are not always recognized right away. Think of Hamilton or Galois or Abel or any of those people. And it takes a long time sometimes for people to absorb what they've done. And I think, though, that there's another issue, which is that it's a double issue, because on the one hand, we're blind to our context, and two, we have the perspectival issue, which is we cannot know at the time what are the important discoveries or where the shift in focus will lead in a discipline. So you have no way of predicting whether people are going to do topology or algebra in 20 years and how that's going to look. And topology may have been a hot field 30 years ago. It doesn't mean it's going to be a hot field in 20 years hence. And that, of course, changes the history of mathematics. In other words, there's some kind of orientation between the two things. Jed, I saw your hand go up. So why don't we get to Jed? Let Jed.
Well, first about Coulomb, but then I'll tell you a couple stories. I like stories. That device was actually used successfully. There's historical evidence for that, and I forget the names, including one guy in Berlin who tried a different device for a while named Simon. But what happened with it, it was no longer attempting to prove the inverse square law. John is right. Generally speaking, it was broadly accepted if it's going to be a 1 over r to the n law, it's going to be 2. And of course, there was the Cavendish experiment. What happened with the device is it became a measuring device, and people did learn how to stabilize it and used it to measure the quantities of charge picked up on the surfaces of different metal configurations and so on. Even Faraday actually used it for a little while. It's not a particularly good device to use, but if you practice enough with it, you can, in fact, as Al found out, get quite good at it, as is usually the case with most experimental devices. Now, a couple of stories. I forget when it was, about 17 years ago, a good friend of Diana's and mine we invited here. It may surprise you who it is. That's Harry Collins, famous sociologist of science. And Harry and I taught a course together, one of these experiment courses, like with Al. And we were, at one point, I said, okay, we're going to do, as Alan Shapiro and I had done, we're going to do the Newton dispersion experiment. And we're going to do it as carefully as we could, and so on. And I said, so, Harry, what we're going to do is we're going to divide into 2 teams. I'm going to have a team where I'm going to try and provide persuasive evidence for, to be realistic about it, what Alan showed you, the unequal refrangibility of light. And you are going to run a team in which you're going to provide countervailing evidence. And we're going to have an argument and see, how it comes out. So he ran first. And then we, or not me, the students I had, they did their demonstration. It took close to an hour and a half. They ran it carefully. And at the end of it, I turned to Harry, and I said, okay, Harry, argue it out. And he looked at me, and he looked at them, and he said, I can't. He simply found that he was unable to, when faced with the actual experience, argue his way out of that. He subsequently decided to invent a new term, I forget what he called it, experiential something or other, which he put in this big book that he wrote on LIGO. In a second instance, I think it was in the late 80s, when there was a comet Kohouta, some comet, which was very hard to see. I was in Germany at a conference in Bielefeld with a number of philosophers and historians of science. I think Bill Newman was there. And we were out one evening with them, and you could barely see the comet. and unless you knew how to look, you really couldn't see it. And one of the philosophers, a very good philosopher named Martin Carrier, kept insisting that it was impossible with the naked eye to see that comet, and that he was very skeptical about historical reports from the past prior to telescopes and so on. And so I said, okay, Martin, so look up in the sky. We knew where it was appearing. I said, look at it. And he said, I'm looking, I can't see it. I said, okay, Martin, here's my hand. I moved it to the side. I said, look at my hand without looking directly at where I said, but try and concentrate out of the corner of your eye. And he looked at my hand. He said, I don't see it. I don't see. Oh, my God. All of a sudden, he saw the comet. It was a question of experience. It was a question of knowing what to do and how to do it. And I don't think we can possibly understand in so many instances what people in the past did without recognizing the craftsman-like experience. And not just in that sort of thing, but in sitting around with calculations on pieces of paper. When Modi and I were doing the Newton stuff, we had all the manuscripts, including scraps and scraps of calculations he'd done over, decades with this thing. And you could see that over time, he was actually getting really good at it. And not only that, he knew how to do it quickly. You think he was using Keplerian calculations or anything? No. He was actually using simple algorithms that you could find in Ptolemaic structures to calculate the stuff that he needed. At first, he was a little weak with it. Then he got you could follow it through. He got good at it by practice. And unless you actually try to get good at what they were doing, so as best you can, I don't think you actually know anything, to tell you the truth, historically. And that means knowing lots of things, as much as you can about it. Otherwise, you wind up telling, it can be informative stories, of course. They're interesting and so on. But if you really want to know, you have to be able to put yourself there as much as possible. And don't be so skeptical about things, actually. I mean, generally speaking, I don't think they lied, although maybe sometimes they did. Noel told me a story about somebody who lied, some astronomer. Yeah, you did. I forget who it was. Yeah,
Next.
Mostly they don't. Anyway.
Comment? Yes, over here, this gentleman.
Let me say a couple of comments about the Coulomb's experiment. Jed's right about the question of really working on the craft or the artisanship. Think about it this way. We walk into an experiment thinking, yeah, these numbers are probably too good to be true. So these numbers are Mickey Mouse exaggerations. Yeah, the device might work, but these numbers are just too cute. At half the distance, 4 times the force, and the numbers themselves were just too cute. So the initial reading, they happen to be separated by 36 degrees. When Halbrand wrote about this, he said, Coulomb probably had his hand on the micrometer to force the initial measure to be 36 when it didn't just randomly settle there. Why not 30? It's a square number, 6 squared. Why not 36.5 or 34.3? So we're dealing with something that's implausible. When you look at great science, superficially, it just looks implausible. It looks too good to be true. Second, you're dealing with the people that came later, and they say, what that first reporter did is not quite right. Do it this way. For example, Faraday and Maxwell, they both say you shouldn't use bare pith, you should gild it. So I spent a lot of time working both with bare pith and gilding bare pith. And then trying to find, is the gilded pith better, as Faraday and Maxwell suggest, or is the original one better? Similarly, and in my opinion, the bare pith worked wonderfully, but you have to actually go through that struggle to discover that. Otherwise, it seems absolutely absurd that you take a stem of a plant, cut a slice off of it, dehydrate it, and then the vascular spongy tissue of the plant, you're going to now polish that into a perfect sphere and hope that the electrons, when they land on it, they don't go into it, they just stay on the surface. It seems absurd until you actually do it. And then you realize, boy, pith is better than foam. I mean, at first you think those idiots use pith because they didn't have foam. But when you actually work with it, you say pith is better than foam. And the same thing happens with when we're trying to make the needle, you take a single silk thread and you cover that with a substance known as Spanish wax or sealing wax. And I did it, and we tried a few things, but it didn't quite work. It didn't behave right. It didn't behave the way Coulomb said. So at that point, I could have just stopped. I could have just stopped and said, Coulomb is a liar. But no, I thought, look, it's obviously the stem. The stem is picking up some of the charge. I need a different material. I ended up using a melted Gillette blade. I mean, a Gillette handle, the blue plastic Gillette. I melted that on my stuffed up, and I used that. I stretched out the plastic, and that was just the beautifully insulating thing. So why did I use that plastic thing? That's what I used. I can sit and insinuate that Hearing had the wrong materials, but so did I. I didn't have the perfect silk thread with the Spanish wax. So when I used the Gillette thing, I got Coulomb's results, which goes to show he is talking about something universal. So ideally, you should be able to get Coulomb's results without using exactly the same thing he did. A couple of years later, some guys at Pittsburgh, they try to replicate it, and Jed sends them some of the glass cylinders so they can carry out the same device. They get numbers similar to mine, but not quite as good, and then they go out of their way to find Spanish wax. So they get Spanish wax. I didn't have Spanish wax, and they get some erratic motions in their needle. And they say, Al, it's not quite working. And I say, well, because you've got the wrong Spanish wax. I mean, think about it. Spanish wax is just 2 words. What you were really talking about is dozens of species of lac insects that live on the leaves of certain trees in India. Soapberry and acacia trees in India. How do you know you've got the right species of lac insect that secreted the right thing so that it's the natural thermoplastic polymer that does not, transmit electricity? So just because you have a product called Spanish wax sold, say, in 2006, it doesn't mean that it's the Spanish wax that they were using in 1785. But of course, each of these steps is a fascinating process, and it's rewarding if it actually works. If it isn't, then it's just
Al,
frustrating.
I have a question for you. You were here for the talk that I can't remember which one of you gave it, where there were different, completely different results for the value of gravity.
Cavendish.
This afternoon? Yes. Now, how do you explain that? How does one explain that? It's not a question of Spanish wax or something. Did they all use different models for gravity?
Only Alan Franklin can explain that. Where is he?
Or does gravity vary?
The real problem, I think, is that the gravitational force is just so weak. If you look, for example, at the gravitational force between the electron and the proton in the hydrogen atom as compared to the electrical force is 10 to the 39th times larger. That's a big number on anybody's scale, and it's just very sensitive. Although everybody thinks they're getting rid of confounding effects, it's just very hard experimentally.
But you still believe that gravity has a constant value, if you could just
Well,
show
I
it.
left you with the question, is there a gravitational constant? Yes, I do believe it.
Even though there's no empirical confirmation of it.
We have very good confirmation of the law. We just don't have any good value for G, for the constant. You don't need to know the constant to get Kepler's laws or all sorts of other consequences of the law of gravity. And what?
You never even use it in the calculations.
Yeah. Yeah. And also, G is one of the few constant, maybe the only constant that is independent of other constants. For example, if you want to talk about the charge of the electron and Planck's constant, you can also get that by measuring the fine structure constant in atoms. And so you have constraints placed by multiple measurements in different ways. But G, as it were, stands alone. It doesn't connect to anything else. And so it's just, life is sometimes hard at the experimental frontier. Well, look, the precision has gotten a lot better. than it did. Cavendish gets, almost it's a 7%.
But your results were still all over the place.
Yeah, but they differ by a lot less than 7%.
Yeah.
They differ by, the claimed latest version is 4.5 parts in 10 to the 5th. That's the worst measured physical constant, but that's still 4.5 parts in 100,000. It's, it's not so bad. But, the hope is it will get better.
Okay.
They should change how they calculate margins of error.
Just one terminology. I think Graham made the comment. He talked about reenactments as opposed to replication. Those are not quite the same thing. Replication, you normally talk about of doing the same experiment. Oh, there's a case I've looked at recently, the so-called pentaquark in elementary particle physics. There were 10 experiments that found it and 16 that didn't. It gets resolved, it turns out not to exist, but it's replication.
I want to take his side for a second and say just one thing, that even though I probably agree with you, I think that the distance between reenactment and replication is smaller than you think. That, that it's a conceptual difference that you're introducing. I think that the gentleman who came up with Graham, I think his name is, came up with reenactment, and I think that there's something to be said to fruitfully think about the similarity between the two things, because after all, the experimenter is not replicating, he's reenacting unless you detach him from the experiment. But I don't want to get into philosophical discussions. Anybody else? I'm going to give 30 seconds to somebody else to talk. Yes, great. Go ahead. Give him the mic.
I mean, if we're still on this for another second, I mean, I definitely find this super interesting, and it's amazing to see the energy that there is around this question. John, I was pitching John Halbrand on a book that may be known to some of you, and it's a strange book, but that would, for those of you who do this kind of work, I'd really recommend it. It's by Frank Ankersmit. It's called Sublime Historical Experience. So Ankersmit is a philosopher of history. The book is not at all about history of science and not at all about experimental replication, but it is about what it means to reach toward historical experience. This category of experience.
Don't get me going on that. I think it's a very good book. I read it, actually, and I think it's a very good book, but he privileges the experience of the historian and his imaginative capacity, only the historian, to recreate the past over ordinary people. And there I found that I bailed ship with this sort of romantic idea of the historian. That's like the romantic idea of the scientist. In the end, all we do is we extend human capacities in a given direction or a given tropism through being scientists or historians or whatever. If they were outside of human capacity, we couldn't do them. So there's something quasi-religious about this glorification of historians, scientists, or whatever it is that I think one has to be careful about.
I actually agree with you that in the end, the book is a failure, and almost all the reviews will agree with both of us.
Right.
But the book poses a super interesting problem, hard and deep, which is what is experience in the past, and what would it be to try to get at it? And while it isn't the same as trying to reproduce an experimental result, I hear a lot about trying to get an experimental result. I hear the word experience coming up now and again. I feel like getting experimental results is heavily theorized in this room. What a historical experience might be is maybe less heavily theorized in this room. So even if you don't go all the way with Ankersmit, who ends up, of course, wanting to talk about how amazing it feels to read Holderlin, and that's not going to help anyone in this room, I don't think. There's still some good stuff in the first couple of chapters of that book on the question of experience.
Anything else? Going once, going twice, it's 5:29 and a half. And so it's going 3 times. You know that there's a dinner, and we'll see you then.